electrical engineering. While I was at IVC, I was also the former vice president of the Applied Science and Engineering Club, and I'm also the project manager for the robotics program currently. Also, I want to point out a few people. Jason Watkins, who was unable to make it today, he is going to be the fall 2012 project manager, taking over my position. We also have Matthias, Dorsa, and Alex, who will aid me in the presentation. And this is also a list of everyone that has been a part of the program so far. And the program's only been up for a few semesters so far, so we're still relatively new. And this is kind of our agenda for today. We're first going to discuss how the program began, our design process that we utilize, the development of our robot systems, and also conclude with a few final thoughts. So first, I'm going to talk about how the entire program came into existence. There's a local business here called Mediabot, so actually just across the street. And pretty much what Mediabot is an after-school program. And at this after-school program, meant for students between grades K through 12, they learn and go here to learn about robotics and kind of how the systems work, a general overview. Kumar, who is the president of Mediabot, actually wanted to host something called the first LEGO League regional competition here at IVC, and we successfully hosted that event last year. What FLL is, or the first LEGO League, is it's a competition, international competition held by LEGO for robotics. And as you can see from the pictures, what it is, it's used a lot of small robotics, if you can kind of tell there. And they all play everything on these fields, these small field game tables. And one issue that Kumar had was how to present these tables, because there was a large audience. It was actually held in the gym, and there was hundreds of spectators. And obviously everyone cannot see the action. So Kumar came to me with a special request to actually create a small team to develop a video system that can actually record the event and broadcast it. So with the team created from the Applied Science and Engineering Club volunteers, we planned, designed, constructed, and operate a live broadcast video system. And on the picture to the lower right, that's kind of something that we broadcasted. To the left, you can kind of see some of us working, and that's the system that we actually used to generate all the content. We had multiple camera angles. We had cameras located on all the playing fields, and also cameras in the audience, and also the stage. And so we developed the system, and it worked very well for the actual event. The video feed was broadcasted on the large projector screens that were in the audience, and also it was broadcasted live on the internet. So if you're unable to attend the event, you can actually watch everything live on the internet. Because the event went so well and Kumar was very happy with our work, he actually donated funding to the Irvine Valley College Applied Science and Engineering Club. The actual club decided pretty much right there on the spot that they wanted to use that to form a robotics program of their own. Because at the time, ASEC, or the Applied Science and Engineering Club, was primarily focused with projects that we already had at the campus, but not necessarily robotics. So, you might be wondering why In and Out is here, how that ties into robotics. We actually had the after party for FLL at In and Out. I mean, it's pretty simple. Everyone likes burgers, so everyone head over there. And I kind of threw out the idea, let's come up with a robot that we can use possibly at the next event that we host. One that can drive around by itself autonomously and be able to record the action in these events. So that's kind of where the idea fostered. So myself and also Brandon Turner, who was also unable to make it today, but is also a longtime member of the Applied Science and Engineering Club and Robotics program, we both drafted the proposal and plan for the entire robotics program. We generated 5 phases, which would cover pretty much the next 2 years worth of content in this program. And the first phase, which we'll discuss today, is about our robotic base. What we decided to do with the robot is to create a base system which we can then add modules on top of, such as the filming rig that we proposed earlier. From then, we actually began to hold scheduled meetings, and pretty much we got right away onto our work. So now I'm going to hand this over to Matthias, who will walk you through the design process.
Thank you, Kyle. My name is Matthias. I will be the new president of the Applied Sciences and Engineering Club. As Kyle mentioned, I'll be talking about some of the design processes. As you see here, this is called what we call the Infinity Design Cycle, which is a process used by engineers to kind of keep your overall project on track with its overall structure. These steps are made in order to maintain a constant flow of progression with minimal setbacks. The first step in a project is to conduct new research. What this does is you identify problems and constraints within current technology or information. Your team analyzes the successes and failures, and from that you derive new design requirements. From here you break off into the either software or hardware portions of your design cycle. The hardware design steps include establishing the design requirements, its characteristics, and achievability. Next, you source parts and you move by a finalized design process. Also, if available, you use existing or computer-aided models to help you simulate prospective tasks. In my case, I use SolidWorks as a basis platform to generate 3D renderings and simulations, and you see some of the pictures throughout our presentation. The next step would be the building. This consists of the collection of your materials used and your various other computer components you're going to be connecting to your robot. You finish up with the actual finalization of the building and manufacturing. This leads into the evaluation point, where you do a figure of merit and identify its successful features. The other side of the design cycle would be the software, which consists of designing feasible requirements and figuring out an available, reusable, existing code within your computer parts. The next step is programming, which includes your language choice and your past skill sets from your programmers, which will highly influence their decisions and evaluation process. And you finish with the evaluation and refining, which includes testing, debugging, and rewriting if needed. Engineers are constantly using the design cycle to better upgrading and evolving their ideas into tools to better our everyday lives. I will now let Dora and Alex explain the robot developments.